Hello, I'm Mark Pollitt, and welcome to Introduction to Digital Forensic Tools. As we start our discussion about digital forensic tools, I just want to share with you a little bit of my philosophy about forensic tools. The first thing to realize is that software tools are just that, they're tools. They're not solutions. The vendors will sell them to you as solutions, and there are lots of people that believe that if they learn how to use the tool, they know how to do digital forensics. And that just isn't true. You basically have to be able to do digital forensics with minimal tools if you know what you're doing. If you don't know what you're doing, you can click on buttons on a tool, but that's not going to help you when it comes time to actually testify and explain to a jury how these things work. So realize that software tools are just that. They're tools to help you do your job more efficiently and more effectively as an examiner, not a substitute for knowledge and skill. Having said that, picking the right tool for the job is important. And there are some tools that are more efficient than other tools for certain tasks. There is no silver bullet. There is no tool that works better than any other tool. There are just tools that work better than other tools for a particular application in a particular situation. And part of the skill of an examiner is knowing what tools to use when. I liken it very much to being a carpenter. Knowing how to use things is important, but picking the right tool for the job is important. But it's more important that you understand how to use a given tool well than it is that you have lots and lots of tools in your toolbox. And I liken it to the difference between watching a skilled carpenter who, with a hammer, a saw, a couple chisels, and a couple screwdrivers, can build a thing of beauty, and watching some of these home improvement shows on TV where in order to hang a door you need to buy 6 different tools, all sold by the vendor that is the sponsor for the show. That's an analogy that I think you ought to keep in the back of your mind as you go through digital forensics training and practice. Part of your job as an examiner is to balance the ease of use of the tool, how effective that tool is. The utility of a tool is how well it works for the given task in the particular situation, and its efficiency. In some cases, while a tool may be really easy to use, it may be very inefficient to deal with the particular data or the type of data or the volume of data that you have. And so you need to select a tool that's appropriate to the type of data, the volume of data, and the kind of throughput that you actually need. There are a number of different things that tools do. Tools can acquire data. Our imaging tools are good examples of that. What Nelson and company say in their book, Validation and Discrimination, these are basically the tools that allow you to compare and contrast things. Most often in digital forensics, we do that by use of hash values, but there are other ways as well. But the ability to identify unique files or unique signatures is a very common requirement in digital forensics. Data extraction, of course, is perhaps one of the biggest things. Obviously, we're trying to extract data from our evidence. And in many cases, that data extraction requires us to recover data. So I would include data recovery in that data extraction part. So not merely being able to copy files, but being able to recover files and copy them out. Reconstruction, and what we mean in that sense is not merely in the Inman and Rudin sense, but the ability to demonstrate a sequence of events within the computer. And there are more and more timeline tools and graphical tools that will allow you to demonstrate timelines with some of the newer tools. We're going to talk a little bit more about them in a little bit. Analysis is the ability to look at all the data there and try to make some sense out of it. And in a lot of ways, we have some very powerful tools, but we also are missing a lot of really important tools. We can do string searches, but we really can't do context analysis very well. We can't do content analysis, and we really can't do a lot of link analysis in most tools. Although some of the newer graphical user interface tools have some networking type tools in there, it's still not the strongest point for most of our digital forensics tools. And this is becoming more and more important as we're getting more and more disparate sources of evidence and from more and more disparate timelines. As an example, merely being able to put a timeline together in a hard drive is a relatively straightforward process. But if you're trying to take the data from a mobile device, from a Twitter account, from a Facebook account, from a network log, and from a hard drive, and try to put them all together and show what happened in what order, that's much more difficult, and we have very few tools that are capable of doing that. And the last part is reporting, and this is the term that Nelson and Company use in their book. I would argue very vigorously that there is no software tool that writes a report. A report is something that's created by the examiner. You may find that the software provides you with some very good notes, but in the end, they are notes. They're a product of the software. They're not your report. So it may be a semantic issue, but to me, it's an important issue. We have tools that operate in a number of different ways. In the very early days, when I first started doing some of my examinations in the late 1980s, the only tools we had were whatever tools were inherent in the operating system. So we could do things like CAT, and we could do things like grep, and that sort of thing. Still, in the Linux environment, we have lots of tools that we can use very effectively that come with the operating system. DD is inherent in almost all the Unix and Linux operating systems. Things like grep, fstat, MD5sum, all of these things are built into the operating system, and we can use them very effectively. In most cases, not most cases, almost all cases, they are also command line tools. And there were a number of command line tools that were developed, particularly in the early days of digital forensics. Gordon Hamma from the Royal Canadian Mounted Police and Danny Mars developed Marsware, and there are a number of others, Mike Anderson's tools. These were all DOS-based but command line. And while they have been almost totally supplanted by GUI, graphical user interface tools, they actually had some real value for two purposes. One, because they were command line tools, they were very, very fast. They were compiled tools that could operate very quickly. The second part was that it was usually possible to script those tools, or in some cases even the tools even had built-in scripting capability that could allow you to take the output of one process and use it as the input of another process. In turn, that be the output of that be the input of yet a third process. And that ability to chain processes in a non-graphical environment turned out to be a very, very quick and efficient way to do a lot of examinations. The only tool I know that allows you to do that in current modalities are the command line tools that are available in SleuthKit. Most people are familiar with the Autopsy browser interface to SleuthKit, but SleuthKit itself are a bunch of command line tools, and typically they run under Linux or Unix, and you can pipe them out and do multiple exams pretty efficiently using the command line interface. Then there's some low-level tools, generally hex editors, and these are tools that we use for validation and verification, and sometimes just to do some basic reconnaissance. And WinHex is a good example. It even has a dedicated forensic interface for it. Some of you may have seen the earlier versions of DiskEdit, and hex editors are very good and powerful tools, but obviously they require a great deal of skill to utilize, not to mention knowledge. What most people think of in this day and age as digital forensic tools are what I would call integrated graphical user interface tools. And these are the typical EnCase, FTK, ProDiscover that most of us are familiar with. They have a nice graphical user interface, they have built in a number of capabilities, and they will create documentation for you to some degree, and will allow you to export information and to view data, and will typically also allow you to do some sort of hashing, etc. And these are the tools that most of us use. Now the good news is that they are kind of Swiss Army knives in that they will allow you to do all kinds of things. The bad news is that you can only do what the software writers and developers wanted you to do. If you want to try to use the output of one and the input of the other, you may not be able to do that. And in that case, in that sense, they're really pretty inflexible. Most of them have the ability to do some scripting, and the ability to do that scripting may be useful if you are a reasonably good programmer. But it's still not quite the same as having all these discrete individual command line tools that you can then pipe and fork and do things with those. Plus, inherently, graphical user interfaces typically are not terribly efficient in terms of their coding. We've taken that one step farther, and now there are a number of network-based tools. And in fact, both EnCase and FTK have enterprise versions that allow for examinations over the network. So now you compound the limitations and the downside, if you will, of the GUI tools, and you add to it the network latency as well. And clearly, it's a lot cheaper and a lot better, even if it is a little bit slower, to remotely do an examination than to fly somebody halfway around the world to image a drive and then fly it back. There are currently some web-based tools, one of which is Online DFS, and that just takes it one step farther. I think it's a matter of time before we start having some cloud-based network forensic tools, or I should say forensic tools that are available on the internet. And the last category I want to look at are mobile devices, and these are the things like Parabin and X-Ray and EnCase, or I should say EnCase and FTK also have modules that allow some limited mobile device examination, far less than what they would market to you, whereas the more dedicated tools like Parabin and X-Ray and Oxygen and some of these others at least try to stay up with the current state of mobile devices. It's a very tough battle. These tools tend to be very expensive, and they tend to require dongles, etc. The state of the art in mobile devices is far less robust than it is in traditional hard drive forensics, in part because the manufacturers of mobile devices do not embed their information in as standardized a fashion as we're used to using in traditional hardware and operating systems and file systems. So typically you have a two-step process for mobile device forensics. The first part is extracting the raw data, and then the second part is interpreting that data and conducting an examination of the actual content of the storage. We have a couple of examples. This is actually one of the network-based tools that we talked about. This is the online digital forensic suite, and it basically allows you to remotely log into another computer and conduct an acquisition and an examination of the tool or the target drive. This is the Autopsy browser, which is the interface to SleuthKit, and gives you an example in this particular case of a timeline analysis, but there are a number of others. This is a well-known, well-regarded tool, and if you know how to use this well, particularly if you have not only a pretty good understanding of Linux and Unix, but if you know a little bit of Python programming, it's pretty amazing the things that you can do with Autopsy. This is the more traditional. This is the latest version of FTK. Tab-based, window-based, drop-down menus, all of the typical things that you expect to see there. Very good for looking at hard drives and for some data sets. They're good for doing searches. They're a little bit more difficult to utilize when you have multiple sources of data and you're trying to correlate data. This is one of the mobile device tools, Oxygen, and it's well known and it's used by a lot of folks. My only concern is that its principals are all Russians. I'm an old Cold War warrior and also a veteran of some of the early cyber attacks, so I have a certain amount of reservation with using this tool, but this is an example of where it's gone out and gotten the data off of a well-known phone, in this case a Nokia. One of the big problems that you have with any of the mobile device suites is you don't know what they don't know. So if you connect a phone and it looks like it can read it, and you take what you see as the only thing that's available, you might be surprised later on to find out that there's other data on there that this tool just didn't know how to get. And so that's gives you a false sense of security sometimes of what you can access. In some ways, even worse, you can spend a lot of money and your bad guy goes out and buys the latest and greatest phone. You seize it and you come back and your tool doesn't read it anymore, and so you have to wait until the next version of your tool supports it. I want to talk just a hair about hardware. Every examiner needs one or more examiner workstations, and in the past the tradition was that we used a really high-end desktop workstation. And then we started using high-end desktop workstations with either fiber channel storage or storage attached networks. Now we're getting more and more to virtualized workstations, and so our need for high-end desktop hardware is somewhat reduced. At the same time, we require higher-end servers that run a virtualization software, whether it's VMware or running Microsoft virtualization. But it has become kind of the wave of the future, and actually it's not even the future, it's here. The box that you see up there is from Digital Intelligence. It's their high-end Fred. What you see there is not only a couple CPUs, but you see a storage attached network that's 32 terabytes. You too can be the proud owner for this one for about $24,000. It will roll on and off a minivan on a chassis of wheels. The thing is about 3 feet high, about 3 foot cube. And then we're starting to see the cloud being used for forensics, and I'm sure that's going to be become common in the future. There's always going to be a need to do portable acquisitions, whether it's rolling your Super Fred into the bad guy's server room and plugging in an Ethernet cable, or going out and making a duplicate of a hard drive at the scene. The box you see at the lower left is one of the ICS physical imaging kits, and those tools have always been around. They come in various shapes and sizes, but at the end of the day, they're basically duplication systems with built-in write blockers. And write blockers, of course, are among the most important of these things. And write blockers can cost anywhere from $100 or $200 up to $1,000. So it just depends on how much money you want to spend. So if you remember nothing else from this lecture, please remember it's not about the tool, it's about the carpenter. If All you know is the hammer, everything in the world looks like a nail. A skillful carpenter can build anything with a screwdriver, a hammer, and a saw. Well, thank you for your time. Thanks for listening. Until next time, have a good day.